Hey everyone, welcome back to the channel. I am Aaheli and today we are starting something super important for all B.Sc Math and Stat student, real analysis. In this video, we will learn some foundational concepts that will come up again and again in your course, like well-ordering property, mathematical induction, triangle inequality, completeness, supremum and infimum, Archimedean property. So yeah, grab a pen and some chai if you need it, and let's dive in. Let's start with our first concept, which is well-ordering property. What is the definition of it? Every non-empty set, let me write it, of natural numbers has a least element. Least means smallest. Let's understand this with an example. If we take the example of A, where the elements are 10, 5, 13, and 20, 5 is the least element. Am I correct? So it means A is well ordered. Why does this concept matter? It helps us build proofs, right? Especially by induction, when we prove something, and defining things like minimum values of a set or in a set. I'll provide all the notes in my blog. Please check that out. Now coming to our next concept of today's class, which is principle of mathematical induction. Now, what is the concept of it? A way to prove that a statement is true for all natural numbers is this. Please understand or remember this notation for natural numbers. All right, what are the steps for it? First, we need to take the base case, which is prove that is true for n equals to 1. And next is inductive step, which is to assume n equals to k. Third is to prove that it's also true for n equals to k plus 1. Like if both hold, then the statement is true for all natural numbers. For example, 1 plus 2 plus 3 plus till n equals n into n plus 1 divided by 2. Now we can prove this by induction. Why does it matter? It's used heavily in proofs, like heavily, just now, as I said of this example. Especially for formulas, series, and proofs, we use this kind of mathematical induction. Now, if you want me to prove this, I can do that for you. Okay, let's do it. First, we need to take n equals to 1 as the first step, which means 1 plus 1 by 2, which is 1. So, Sn is true for n equals to 1. Now, let Sn is true for n equals to k. Therefore, it will be 1 plus 2 plus till k. Then the formula will be k plus 1 by 2. Right? Now, coming to this, when we take k plus 1, then how will we write it? 1 plus 2 plus till k plus 1. For this, what will be the value? k plus 1 by 2, which is this value for this, and plus k plus 1. Therefore, if we simplify it, k plus 1, k plus 2 by 2. Now, if we see for the formula of this, if we put k plus 1, then it's coming the same. Hence, we proved it. Please try on your own too. Then you'll understand it better. Now, coming to our next concept of today's class, which is triangle inequality. For any real number or vector, x and y, we have got two formulas. One is mod x plus 1 ay is lesser than or equal to mod x plus mod y, and mod x minus y is greater than or equal to mod x minus mod y and whole mod. If we take an example where x equals to 3 Just let it x equals to 3 and y equals to minus 5. For the first one, let's do it. 3 plus minus 5 mod equals, what is it equals to? Minus 2 mod, which is 2. Now for this part, mod 3 plus mod of minus 5, which is 3 plus 5 is equal to 8. So we get 2 is lesser than or equal to 8. So this is true. We proved it through this example. And for the next part, 3 minus of minus 5 mod, which is 8 mod, which is 8. And mod x, which is 3 minus 5 whole mod, which is minus 2, which is 2. Here we get, so 8 is greater than or equal to 2. Then again, the statement is true. We have proved it, right? Now, why does this matter? Why does this concept matter in basic honors course? This inequality is used in distance and convergence concepts. It tells us that the shortest path between 2 points is a straight line. So, for example, this is actually used in a distance formulas where A to B to C can never be shorter than A to C. This is basically the concept of distance, if I put it simply. All right. Now coming to our next concept of today's class, which is completeness. Now, completeness property. What is completeness property? We use it for R, which is real numbers. Now this is again a notation. Notation of what? Real numbers. What is the definition of it? Every non-empty set of real numbers, let me write it for you. Non-empty set of real numbers that is bounded above has a least upper bound. I'll explain these terms in the later part, which is called supremum. We'll come to supremum and infimum in the next portion, all right? Now, this is also a real number. This is what the definition stands. Every non-empty set of real numbers that is bounded above has a least upper bound, which is also known as supremum. That is also a real number. We will understand this concept better with an example. Let A equals x belongs to R. R is, what is R? Real number. And x is lesser than 3. Now this set is bounded above by 3, 4, 5, etc. and it will go on. So from here you can understand that the upper bound is not limited it's not bounded, and this 3 may not be included or may be included, but we will take this as our least upper bound because this is the least number from where the upper bound is starting, right? So what do you get? What is the least upper bound here? I'm writing in short just for the sake of time management, but please understand it. So yeah, this is the completeness of R. Why does it matter? This is what makes real numbers different from irrational numbers, right? This is what makes real numbers special. Rationals don't have this property, but real number does because it's complete. This allows limits and convergence to work correctly. Now, if we try to understand supremum and infimum, let's come to our next topic then. Very easy thing. Infimum. All right. What is supremum? Just now we have discussed the least upper bound of a set. And what is infimum? It is greatest lower bound of a set. Why is this greatest and this is least? We will understand this with an example. Okay. Let's take the example where let b is equal to 1.1, 1.2, 1.3, and 1.4. Now here, which is our least upper bound? 1.4, of course, it's the greatest number here. And what is our greatest lower bound? Is this 1.1. Because the numbers which are below 1.1 are also lower bounds. But what is the greatest of it? It is 1.1. So just like it, numbers above 1.4 are also upper bound. But we will take 1.4 because it's the least upper bound. All right? Even if maximum or minimum are not in the set, supremum or infimum can still exist. This is what I mean. Like here in this example only, 3 was not included. Even though 3 was not in A, 3 was the supremum. So this is what I mean. Now, why does this concept matter? It is used to define limits, completeness, and boundedness in analysis. Now, the last topic of today's class, which is Archimedean property of real number. Notation of real number. What is the definition of it? Given any two real numbers, A and B, with A greater than 0, there exists a natural number n, such that NA is greater than B. The meaning in simple terms is that no matter how big B is, if you keep adding A enough times, you will eventually cross B. Like for an example, if I say, let A equals to 0.1 and B equals to 100, then N equals to, if we take, which is 1000, works because 1000 multiplied by 0.1 is 100, right? So that's what I said. No matter how big B is, if you keep adding A enough times, you will eventually cross B. Now, why does this concept matter? This proves that natural numbers are unbounded in real numbers. This is a very important concept. I'll write this down for you. Please note it down. Natural numbers are unbounded in real numbers. It's used to prove results about convergence and bounded sets too. So yes, now if we make a summary table of whatever we learned today, I'll just tell you verbally, maybe, or write a few words. Our concept was well ordering, where it meant every set of natural numbers had the smallest element, right? Like even the natural numbers has the smallest element, which is 1, all right? So yeah. Now next concept was induction, which means a method to prove things true for all natural numbers, right? Then the next part, or the next concept, which is triangle inequality, where we discussed about that direct path is the shortest. And then the next concept was completeness of R, where we found, or where we discussed about supremum of bounded sets always exists in real numbers, right? And then we discussed about supremum and infimum, where supremum means least upper bound and infimum means greatest lower bound of a set. And then we discussed about Archimedean property, where we discussed about that natural numbers can exceed any real number by multiplication. All right. So yeah, that's it for today's real analysis class. We covered 6 core ideas that will help us build stronger proofs, understand limits, and deal with sequences and functions later. If you found this video helpful, don't forget to like, share, and subscribe. So yeah, keep learning, and I'll see you in the next one. Bye. Please take care.